Hey, what's up everybody? It's Caleb from Caleb the Video Maker 2, and I am going to be doing a miniature series over MySQL stored routines. Just so you guys can get an idea of what the series is going to be like, I'm just going to try and do a video by video. I have a rough outline of what I want to do, but I'm not planning every single video out, so we'll see how this series goes. If I make 10 videos and I have some more ideas, I might throw some more in there. The level of difficulty for this series is beginner. It's basically a continuation of my 67-part MySQL series, and we're just gonna continue where we left off, go over some more topics, but it's all gonna be introductory level. So to get started, what is a routine? Well, if you think of the word routine, and we're not talking computer science here, a routine is something you do continually. You wake up and you have a routine for your day. Well, it's very similar in MySQL. With MySQL, you can make a routine and then you can call that routine multiple times. So let me just illustrate this with some boxes. Also, I just thought I'd show you guys my sweet decal. My dad drew this. All right, so let's say this is a routine, and you have a bunch of code in there, and you want to execute that a number of times. Like it might calculate something, or it might be some kind of algorithm or something like that. And you have a couple of options. First, every time you need to run that algorithm, you could just write it out yourself. And then you'd have to memorize all that code or go reference the file of where you saved it. And then once you need it again in the future, you could write it out again. And clearly you could see why this is a problem, because you have a lot of repeated code and you have to memorize a lot of things, and it makes your life as a programmer, a database developer, or database administrator a lot harder. So an alternative is to just have one routine, and then whenever you need to execute this stuff, you just reference it and you call it, you invoke it. There's a bunch of different words you could use for that. And then if you need, you can pass some data in. So let's say this is an algorithm of like calculating a discount or something stupid. I don't know. Well, you could pass in the price. So let's say you pass in $100, and then the stored procedure does the magical calculations, and then you get the new discounted price. That's just an example. And we'll be getting into the details of the different kinds of stored procedures and all that good stuff. So hopefully you guys are excited. I'm excited. As you go through this course, you're going to get a rough overview of all of this stuff. I'm not going to go super in depth. We're not going to make this reference material, really. This is more for education's sake. So by the end of this series, this little miniature series, you're going to have a rough idea what all of these things are, and it's going to help empower you in your database development. But it's not going to make you an expert. This is to get your hands dirty, get you started on stored routines, functions, variables, and some more programming-like things like procedural programming and all that good stuff with MySQL. So, continuing the 67-part series that everybody loves, this is the next level, a little bit more difficult stuff. We'll see how it goes, and let me know what you guys think of this series, and if you have any suggestions for videos, leave them in the comments, because I'm kind of open for ideas. So thanks guys, and I'll see you in the next video. Welcome back to your second video in this MySQL stored routines series. And my dog's over here making a bunch of noise, so I apologize if you hear him eating some food or whatever else. Anyways, the way this series is kind of going to work is I'm going to introduce topics and not exhaust all the details of that topic. This isn't supposed to be designed like an in-depth advanced course. The reason being is I want you to get the rough overview, so that way you can look at the big picture rather than getting lost in all the details and not really understanding why. To begin, we're going to start with the topic of variables. And just the word probably makes some of you cringe because it brings back memories of math class in high school. I think math can be fun if it was taught right, which it probably wasn't. So I'm going to try and teach it right. And this video is going to look at variables from a mathematic standpoint. What is a variable? Well, it's something that holds data. X. Everybody knows X. It's basically a variable that stores some number or some formula. So then if you do 2x, whatever x is, you multiply it by 2. It basically allows you to simplify your math problem. So for example, x could equal 5. And then you could either do 2x or you could do 5. And these are essentially the same thing. So wherever x is, you can basically take that data and replace x. Now, you might be wondering, well, what the heck is the point of this x here? Why don't you just put the 5 there? And I know that's a very valid point, and that's why a lot of people don't understand variables when it comes to math. You could put it in line like that every single time, but what if x is something like 5 squared times 42 divided by 32? Well, you could take all that and put it in for x, but this is much simpler. It looks more appealing to the eyes. Sometimes we use variables simply for the sake of making things easier to read. So one use for variables is simplicity. Second reason is to store unknown data. So what do I mean unknown data? Well, it's not all of the time you can type in the data inline. And when I say inline, that'd be essentially what I wrote earlier, 2 times 5, where instead of writing x, you put the data inline in whatever you're writing. For example, if we're working with a database, we might take a value from the database and assign it to a variable to use later. If we wanted to hard code that in and put it inline, we'd have to know what that data value is up front. And sometimes that's just not reasonable. Let's say we have a classroom and we need to calculate who's going to pass and who's going to fail. The grade's over, so it's not like we have to predict the future. Everyone already has their grades in. All we have to do is take all the people who passed a certain class or whatever. So we might have a score that's considered passing. So let's say 66 is considered passing. We could store this in a variable. So we could call it x, but just to make it more simple and more readable, we can name it passing. Now, in our SQL, we could do something like select. Then you could say something like all of the students' first and last names. And then you could put a where clause. Then all you got to do is take the column for their grade, probably named grade, and do something like greater than or equal to 66. And you might be wondering, what's the point of this variable? Well, we're actually not using it here. We could very well just put passing here. So what's the benefit of putting passing here instead of 66? Why not just put 66 in here? Well, this is a very simple example. In some situations, it might be about something else, and this is some kind of huge algorithm, and we don't want to put it in line in our SQL because it makes it sloppy. Another thing, if you come back 3 years later and you read this, you know exactly what the heck it's talking about. Because if you read it in English, you're selecting everything where the grade is equal or greater than passing. But if you just put 66 in here, and you don't have this up here, you might come back and be like, I know I'm selecting something, but I don't really know what, and I don't remember what the significance of this number is. That's an example of simplicity. We're assigning useful names to data, and then we can use that name in place of directly using that data. So instead of using 66, we should definitely use passing. So that's kind of the summary of the start of variables. In the next video, I'm going to be giving you the syntax. Like I said, this is kind of just from a math perspective. Next video, we'll get the syntax on how you declare variables and give them values. So we'll see you then, and catch you then. I already said that. Peace. Subscribe. I'm so bad at this, Aaron. If you have something like... That scared me. My light just fell. Yeah. Welcome back, everybody. In this video, we're going to be discussing user-defined variables. And this is one of the kinds of variables that MySQL has. I think there's actually 4 different kinds. But just to get started, we're going to start with this, and maybe after we get over all the good main stuff, we'll go back and go over in more detail all these different things. But just for now, I just want to get on to what's important. So, user-defined variables, they are a type of variable that have a very small scope. So whenever you study variables, I can guarantee you this word will come up. It talks about the lifetime of the variable. So when you make one of these user-defined variables, it doesn't last for eternity. It's not like a table or a database in your database management system. It's just within your, I guess you could say, your client, the place where you're typing your SQL commands, whether it be the terminal or whatever. The lifetime is that session. So if you open your MySQL terminal and then you create this variable and then you do some commands and then you X out of it, well then that variable no longer exists. You can't reopen it and reference that variable. So different variables have different scopes. This one is a session scope. There's two more terms you're going to need to know, and that's declare and initialize. Essentially, declaring a variable is telling MySQL, hey, here's this variable. I don't exactly know what the data is going to be inside of this variable. I just know that this variable needs to exist because I'm going to use it in the future. Initializing is when you give that variable a value. So you can actually do this both at the same time. You can declare and initialize a variable in one statement. And that's usually what we're going to do. I just want you guys to be clear that when you're studying this, there's a difference between declaring a variable and initializing the variable. And if you're not clear on the difference, you can come up with some weird bugs in your SQL statements or whatever, because you might be trying to use a variable that needs to be initialized, but it's only been declared, and so forth. So now, enough of this vocabulary garbage. Let's get on to the MySQL syntax for declaring a variable. Making a variable is super easy. All you gotta use is the set keyword. Oh, Onyx, did you fart? Oh, Aaron, was that you? Set. And then you put an @ sign, and then whatever the name of your variable is going to be. That's all you gotta do. Set, the variable name, and then the value. We just initialized this variable, and now we can use it in all of our other SQL statements. So that's all for you guys. Thanks for watching this series. I'll see you guys in the next one. Ha, I'm kidding. It's not over yet. For now, we're just going to go over a little bit more theory in the next couple of videos, and then we'll start getting on the computer and typing some junk out and making some cool SQL scripts. But for now, memorize the syntax. Set, @ sign, variable name, no space there, equals value. Semicolon is optional if you only have one statement, but you probably have more if you're declaring a variable. See you guys in the next video. Be sure to subscribe. Welcome back, everybody. In this video, we are going to be discussing a different way you can make variables in MySQL. And these are still user-defined variables, so they have the same scope as the way we talked about in the last video. And I'll be getting into the reasons why there's different ways to do it in just a minute. But the way this is going to work is using a select statement. So first, let me write the way we made a variable in the last video, and then I'll compare it to the new way. This was the first way I taught you how to make a variable in MySQL. You use the set keyword, and then you give it a name. In programming, this is known as an identifier. Whenever you have an identifier, you can change it with whatever you want. So you don't have to make this @ passing. You can make it @ whatever. It doesn't matter as long as you put an @ symbol so MySQL knows it's a variable. So that's the identifier. And then you use an assignment operator and you assign the value 66. So in this situation, this is the assignment operator. And this can be different than the comparison equals operator, which we'll be discussing in just a minute. So this is kind of like an overloaded operator. In this situation, we're using it to assign a value to a variable. But later, we'll see how this can also be used to compare things in a comparison situation. And that'll make more sense once we go through that, but just be aware of that for now. Finally, we give it the value 66 and use a semicolon to tell MySQL this is the end of the statement. The new way to create a variable is within a select statement. The very first thing you need to do is replace set with select, and then you use the identifier just the same. And then you need to assign it a value. And in this situation, the assignment operator looks a little bit different. You are going to use a colon and then an equal sign. Once you have that, you can give it the value. You can also see here you can use different data types with your variables. So to summarize, the only two differences is this change in keyword from set to select, and then this change in the assignment operator to a colon equals. But what's the main difference here? Well, this one up here, this is just going to create the variable. But this one is going to actually return that value of whatever that variable is. If you guys have watched my other series, you'll know that select is what we use to get information. It's not always selecting something from a database. So if you know this, you can put a from statement and you can say what table you want to get that data from. But you can also just put an expression in there. So an expression is something that is evaluated to a value. An example is 5 plus 5. If we were to do something like select 5 plus 5, we are going to get back a result table that says 10. So normally when we have a result table, the column name is up here. Instead, it's going to be the expression, and then we'll get the result under that. So this is what this is going to return. So if you go select 5 plus 5, you're going to get this result table. A very similar thing happens when we use the select command to create a variable. When we run this command, it's going to take this, it's going to put it as the header of that column in that result table. And then the result is going to be whatever the value of the variable is. So that's one of the big differences between using the set and the select command to create variables. In the next video, I'll be explaining why we have to use this colon. Onyx! Can you drink your water when I'm not making a video? In the next video, I will be explaining why you have to use this colon equals. In that one, we're actually going to be getting on the computer and using this pretty cool tool to run SQL commands. I think you guys are going to like it, so we'll see you then. Be sure to subscribe, and yeah, that's about all. So, yeah, bye!
Like me down here.
And go away, I'm making a video. Come at me. Did it?
It hit my tailbone.
I'm sorry. Love you.
You don't.
I didn't mean to hurt you. Owned. Welcome back, everybody, to your MySQL Stored Procedures and Functions series. And just so you guys know, me and my wife are just chilling at my parents' house where I make my videos, and we forgot every essential that we'd ever need, including our suitcase and my microphone. So if the audio is a little whack, I'm sorry, but we'll try to get our microphone sometime soon. But for now, I'll just get started. Hopefully it's not too bad. The very first thing, guys, is I wanted to introduce you to a very awesome tool. This is called SQL Fiddle, and you can find it at sqlfiddle.com. And what this does is it allows you to type SQL commands and use multiple different database types. But you don't have to download anything, and it's really cool because once you type something up, you can actually save it and you can send it as a link to somebody to show. So to start, we're going to build a simple database over here on the schema panel. So to begin, we're going to create a table, and with SQL Fiddle, you don't have to say create database or anything, you can just start with your table. So we can just say create table, and then give it a name, and we'll just call it pets. We're going to make a little table for pets and list their names and their owners and cool stuff like that. Now within parentheses is where we put all of the columns that we want in this table. So the very first column you're going to want is an ID. We'll also have a name, owner, sex, birth. That's going to be the day they were born. And then we're going to have a death. And this is not the correct way you're going to want to do this. I just wanted to write out the columns. So next thing we're going to need to do is put the data types. So we're going to have an int, varchar, and then you can give an amount, so how many characters you want it to be able to store. Let's go with 50. And owner, in a more complex database, you might have another table that has a list of owners, and you might have this as a foreign key. But for now, this is okay, so we're going to have that as varchar as well. Sex, we're going to make that a character, just one character, so we're just assuming either M or F. Birth, that's going to be a date. Same for death. That's not quite all we need to do though. We need to go back and we need to go a little bit more in detail for this ID. We need to tell it that this is going to be a primary key. And that's going to keep everything unique. It's just going to be a generated number. The auto increment keyword is going to make the database automatically increase the number of the ID without us having to worry about it. So when we insert data into this database, we don't have to worry about giving it an ID explicitly. It'll just do it itself. So a couple other things I want to add. I think I'm going to throw in a species here. Let's do it after the owner. And we'll make that varchar as well. Or varchar, however you want to pronounce it. And another thing, I'm just going to put some of this stuff on a new line so it's easier to read without having to scroll over. And it should work just fine. So that is our table. And just so you guys can see how SQL Fiddle works, we create our table and we can just click Build Schema. So we've created our database and now we actually want to insert data into our database. Well, where do we do that? Do we do this on the Schema panel or the Query panel? Well, I can tell you ahead of time that we're going to want to do it over here on the Schema panel. That's because in SQL there's two types of languages. Here, I'll just write them out here so you can see them. There's DDL and DML. And that's data definition language and data manipulation language. I think I have some videos over this in my database design course. But for now, data manipulation language includes insert statements where we put data into our table. And all of data definition language and data manipulation language is going to go over here in our schema panel. And it's really easy to figure that out because here, like if we build this schema and then we do an insert over here, you can see down here DDL and DML statements are not allowed in the query panel for MySQL. Only select statements are allowed. Put DDL and DML in the schema panel. So that needs to go over here. So we're going to create some data and put it inside of our table. The very first thing you're going to want to do is give this semicolon so that way we can put multiple statements in this schema window. So to put data into the table, we use an insert command. And because this is a new command, I'm just going to put that at the beginning. And then you can say into and name the table that you want to put the data into. And that's going to be pets. Then what you're going to do is put parentheses, and here you're going to define all of the columns that you want to put data into. So we could put an ID here, but like I said, the database is going to worry about that for us. So we are going to go ahead and put every other column in here. And in this situation, I didn't mark any of these as not null, but if you want to force somebody to put data in one of these, you can just put a not null keyword there and it should work just fine. But it's really not that big of a deal because we're just kind of playing around with some SQL here. So we're going to put name, owner, species, sex, birth, and death. And then what you need to do is put values, parentheses. And here is where we pass in the values. And sometimes it's helpful if you get confused on how many, is just to kind of put the commas in ahead of time. So first let's look at the data types. We have name, owner, species, sex, birth, and death. Those are all going to be stored as strings, or we're going to need to give it strings. So that's going to be the name, that's going to be the owner, that's going to be the species, sex, birth, and death. And yes, you do pass in dates as strings. As I mentioned earlier, this owner might be a foreign key to another table. And if that's the case, you're probably not going to use a string, but an integer. And if that's the situation, you just leave that like that, so you know you need to put an integer in there, because you put the ID of whatever owner it is. So to begin, let's give it a name. Let's say Snowflake. The owner, just a little girl named Ewen, because she can't say her R's yet. Species, let's say it's a robo hamster. And for the birth, the format you're going to want to use is year, month, date. Same for the death, but we'll just leave that null. And for nulls, we don't want to put that in a string, or it'll be stored as a string that has null, which isn't going to work for the date data type. So that should be good for that. But how do you give it another row? Well, you can just put a comma, and then you can give it another parentheses. Cuddles, owner Frank. This is going to be a kitty. Oh, poor guy. He only lived one day. Oh, I think that's everything. I don't think I screwed anything up, so let's give it a try. Okay, unknown column, birth, and field list. What did I screw up? Biff. That would explain it. And there you go. We made our database. That's why SQL Fiddle is really pretty cool, because we don't have to worry about actually creating that database and making a table. If I want to change something, I can just type it in here and then build a schema, and then boom, you're good to go. But obviously you need to make sure you have correct syntax. So now over here we can give our commands, and that's what we're going to be doing in the next video now that we have our database and table created. So thanks guys, be sure to subscribe, and I'll see you guys then. Thanks, bye. Welcome back guys. In this video we are going to be creating our MySQL variables. And something awesome about SQL Fiddle that I wanted to share with you guys is that when you create something like this, it has a unique identifier. You can see up here in the URL bar we have this code here. And what you can do is you can take this code, and I'll show you guys. Let me open a new tab and paste that, and wow, it opens up to exactly the same thing. So that means as I code stuff, I can put this little identifier in the description, and you can open it and jump right to where I am if you get lost or can't seem to figure out what I'm doing. And then you'll be right up to speed with me. So that's really cool. So be sure to check the descriptions for these, including this one, to get right where we are right now. For the rest of this video, we are going to focus on the query panel. Let's create some of our own variables. We start with the select command, and then we give it a name. Let's call it variable 1, and we'll give it a value 5. The other way is using the select. So we can say variable 2, and then we can give it a value using colon equals hello. Make sure I put that as a string. And now let's run this SQL. So as you should have expected, the set did not return anything, but this one did, and it returned the value of the variable. Perfect. Now let's just go over a little more in-depth example. Let's create a couple variables. Variable 2, we'll assign it the value 10, and then let's create another one. Variable 3, and assign it the value -7. We can reference multiple variables within a select. So let's try select variable 1, variable 2, and variable 3. And now we can see all of our values down here. And we can actually add those together. So let's say we want another column, and we're going to say variable 1 plus variable 2 plus variable 3. Awesome. Seems to be working just fine. Another thing, we can even assign this value to another variable. So we're going to make it variable 4 colon equals. Let's run that. Yeah, and it's still 8, so everything seems to be working good. And then later I can reference variable 4 again. Gotta remember to put my semicolon. Now we get 2 responses, 8, 8. Great, so everything's working out. Now let's go over an example of what can happen if you forget this colon. Let's just start from scratch here. Let's say we have a variable, and we're going to name it ID and give it the value 1. And we're going to select everything from the pets table where ID is equal to ID. Let's run it. Great, so we're getting back this row. And that is the row from this table over here that we want to get. Well, let's say somewhere in our SQL we want to change that ID. So we make a select and we put ID colon equals 2. This should work out just fine. Make sure we put that semicolon, and let's run it. Perfect. We are now getting the second row in our table. Well, you could see if we forgot to put this colon and we ran it, the response is still the first row. So that might confuse you if you don't know what you're doing. Another thing, the response from this select here is a 0. What does that mean? Well, this is actually being evaluated as true or false. So we're asking, is ID equal to 2? And if it's false, it's going to return 0. If it's true, it's going to return 1. So let's turn this to, let's say we set this to 5, and we check to see if the ID is equal to 5. Let's run it. And the response is 1, so it is. And that's awesome here, because we can check the value of a variable. But it's not always awesome if we're trying to assign it a value such as 50, and then we get a 0 as a return result. That's not what we're expecting. So make sure if you're assigning to use the colon equals. And also, even in set, you can still use a colon equals. And a lot of people will do this just for consistency's sake, so they always think colon equals as the assignment. That will prevent them from accidentally leaving it out in the select, just because they know anytime they need to assign a value to a variable, they have to use a colon equals. And then they won't get funky results, which this isn't going to do anything because we're selecting a row that doesn't exist, the ID of 5. Another thing, guys, I wanted to show you is you can always search things on Google and find the MySQL reference, and it is really cool. So here is an example that's very similar to what I showed you, where we're creating some variables and then we're selecting those variables and then making an assignment within that. It also talks about using the colon equals and just the equals. And it says how the one without the colon is treated as the comparison operator. But for now, that's all I have to say about variables. Thanks, guys, and I'll see you in the next video. Bye! Welcome back, everybody. This video we are going to talk about stored routines. There are two classifications of stored routines. There's stored procedures and stored functions. We're going to be discussing both of these in this series, but we're going to start with stored procedures. They have a different purpose, but the way they work is very similar. So once you get stored routines, learning stored functions is really not that big of an issue. Eventually, we're going to do a video comparing the differences between the two so you have a clear distinction of when you need to use a stored procedure and when you should use a stored function instead. What is a stored procedure? A stored procedure is just a section of code that we can call. We put all of this code in here, and then later we can run the call command, and we don't have to put all of that code inline. And we talked about all these things in the first video, and I think a little bit with variables in the second and third video. But essentially, we want to avoid putting things inline as much as is necessary. So if we can take a lot of code and put it in its own stored procedure, we can then call all these different stored procedures as needed. So if we need to do one thing with our database, we could call this one, or we could call this one, or we could call this one. And sometimes these take what's known as arguments and parameters. And what that is basically passing data into the stored procedure. So we could pass in like a number that's needed, and it's going to do something with that number. Starting off though, you can make stored procedures without parameters. For those of you with more programming experience, you can think of stored procedures as creating an API to your database. And if you have no idea what I'm talking about, don't worry about it, we're going to discuss it in a future video. But just keep that in the back of your mind if you guys know what an API is. There's a couple of different ways you can work with a database. As you get more experience with MySQL, you begin to do more things when it comes to interacting with the database. Just starting out, you usually just open a client, type in some basic select commands, and get results. But after doing it over and over again, you're not using your time optimally. As you get more experienced, you start to think about ways you can save time. One way is saving SQL scripts. An SQL script is just a file that you can run, and it's going to give back your result. So we could make an in-depth select statement and then save it as an SQL script, and any single time we need to run this command again, all we got to do is find that file and run it, and we get the results that we need. This is useful, but it's not optimal in all situations because now we have a bunch of SQL scripts, we have to organize them, put them on our file server, and then open them, and they don't take parameters. That means we can't just pass data into them. We might have to open the script, edit some things, and then run it to match that certain situation that we need. This is different than a stored procedure because with a stored procedure, you can just find it, pass in data as an argument, and you get the result you need for that situation. So I would vote that stored procedures are better than SQL scripts. I ain't saying that you should never use SQL scripts, but it's always better to lean on stored procedures. That's because they are actually connected with your database. So let's say this box here is your database, and you can have all kinds of tables in your database and all kinds of goodies like that. Well, one thing you can put in here are stored procedures. SQL scripts are a separate file. With stored procedures, when you open your database in your database management system, you can find all of your stored procedures and call those from your code. And that's just really super useful. SQL scripts are great for some situations. Specifically, when you're setting up a database, you can just save the way you set it up and reference that later. But they're not always the best in every single situation. You can also think of stored procedures as extending the MySQL language. That's because once you have your stored procedures made, you can call those, say the procedure that you want to run, and it will do something. So you can basically make these SQL commands that do in-depth things that you couldn't do by default with just MySQL. You're using MySQL to do this, but you end up with commands that are much more useful to your database. So in your SQL, when you actually want to create your stored procedure, you are going to have to worry about something called a delimiter. A delimiter is a fancy name for the character you use to tell MySQL that a statement is over. So right now, by default, it's a semicolon. And that's kind of like the standard when it comes to programming. There are tons of programming languages that end all of their commands or their statements with a semicolon. We are going to have to change the default delimiter when it comes to stored procedures. We can do that with the delimiter command and then put, for example, // And now when we go through here and make a bunch of commands, MySQL sees this as being part of your stored procedure. It's kind of weird. It kind of makes you think, they probably could have made a way where you don't need to do that. But that's just how it is. You're going to have to remember to put delimiter and then whatever you want. A lot of people also use $signs, but it doesn't really matter. And then when you're done, you can put the end keyword, whatever your delimiter is, and then say delimiter again, and then follow it with a semicolon. That'll tell it to go back to the normal standard semicolon to be the delimiter. That's all I'm going to discuss in this video. That'll give you a rough overview of everything you need to know to begin working with stored procedures. In the upcoming videos, we'll discuss the API thing I was talking about and also show the code for creating a stored procedure. And then eventually we'll be getting on the computer, typing up some commands and showing the results. See you guys then. Be sure to subscribe, and I'm hoping you're enjoying the series. If you have any suggestions, leave a comment below and we'll see what we can do. Thanks. Bye. Welcome back everybody to your MySQL Stored Procedures and Functions series. In this video, we're kind of doing a part 2 to creating stored procedures. To begin, we had to change what was known as the delimiter. That's what separates statements in MySQL. The default is a semicolon. To change that, all we have to do is say delimiter, and then you just say what you want the new delimiter to be. So we'll go with 2 forward slashes. And then eventually you're going to have to change this back. But before you do that, you okay, boy? Before you do that, you're going to want to start your procedure. So to do that, you use the create procedure command. And then you give it a name. And then you just put parentheses. So this is where later you will give it parameters. But for now, we'll just keep it at that. And then you say begin. That is how you start the definition of a stored procedure. We have a stored procedure with the name friends, and it takes no parameters, and we can use the semicolon within the definition because we use this delimiter here. That way the semicolon can be passed to the server rather than being interpreted by MySQL. The next part is what I mentioned in the last video, which is the end keyword, followed by your new delimiter. So basically we're passing the end command and then we're ending that statement. Finally, we can change the delimiter back to the semicolon. Perfect. You just made a sweet procedure that does absolutely nothing. But this is the shell of what your procedure is going to be. Earlier when I drew that box that represented a procedure, that was this. So think of this as a giant box. And now we are exploring the innards of this box object thing. Now, where do you actually put your code? Well, I'm assuming you guys can realize that the code goes right here. So you can put whatever the heck you want right here, and that's what's going to run when you run this procedure. So since we're having this procedure called friends, we'll just say select everything from friends. So let's just say we have a friends table, and that's what it's going to do. Kind of ran out of room there, but it's okay. So this is a procedure that is going to return everything from the friends table. Another thing I wanted to mention is that this delimiter thing, that's only going to be applicable for some situations. For example, if you're using the MySQL command line client, you're going to need to use this. But if you're using something like phpMyAdmin or this SQL fiddle tool I've been using, there is a different way you need to tell it that we're using a different delimiter. And we'll get into that when we're starting to create some stored procedures, and it'll make sense when the time comes. But just I thought I'd let you guys know if you're typing this stuff in phpMyAdmin, for example, and you're getting errors, that's probably why. Now that you have this procedure created, how do you go about actually using it? It's very simple. You use the call command. Call friends. I bet you none will answer. Kidding. This is much simpler though than actually doing whatever the procedure code is. Even though our procedure was so simple and it only had one line of code, this is still much shorter than writing out the code yourself. You can see this only uses about 2 words and this uses 4, kind of. So if you're working with a team and the team doesn't exactly have lots of SQL experience and you want them to be able to write SQL, that's exactly what you want, all you gotta do is create a procedure and then they can just call it and they don't have to worry about writing out the code like this. And that is a perfect exit to introduce the next video. So I will see you guys then. Be sure to subscribe. Welcome back, guys. This is where we left off in the last video. We were comparing calling a procedure to just typing the code that was within the procedure. And we came to the solution that just calling the procedure was a whole lot easier. But there's an extra layer of why this is way super cooler than just doing this. And that has to do with security. And now, please do keep in mind this is an introduction course, so we're not going to dive deep into security and user roles right now at least. But this is important to know from the start, so I'm going to briefly explain it. And then if you find that this material is useful, you can take the extra step, research it, and figure out what you need to do in your situation. This might just be a good starting point. So this video is going to be about APIs. API is an acronym that is thrown around way too much in programming, but it's very important, so I would recommend learning it if you don't already. It stands for Application Programming Interface. So what in the world is an application programming interface? Well, let's first talk about interfaces. And you could describe interfaces in like 50 different ways. But let's just kind of think of a couple of them. So here we have this beautiful city. We don't just want strangers walking in and looking around and stuff. We want to build up this crazy wall that only lets certain people in. This is such an awful drawing. Plus, this isn't even applicable today most of the time. Anywho, people come in and just pretend this is in 3D space, so it's like all the way around the city. So people are coming in, they're like, hey bro, let me come in. I have cool things like weapons, and I want to take over your village. And you're like, nah bro, that ain't gonna happen. So this wall is a separator from the city. And the only way to communicate with the city is through this wall. So if you're actually a good guy and you're bringing in some transports and with some goods and stuff, you can get in the city. But if you're a bad guy, you can't. It's an awful example of an interface, meaning that you interact with the city through the wall. You know what? This example is awful. Let me give a different one. Alright, so you have a car, right? Because that's what cars look like. And in here you have like an engine and other junk. But how do you drive this car? There's only like 2 or 3 things you need to worry about. And that's the steering wheel, or the beach ball, the gas pedal, the brake, the seat belts, and a couple other things. That's about it. These tools act as an interface between you and the car. The only way you interact with this engine is through the interface of the steering wheel, the gas, and all that stuff. And now that I gave you two useless examples, let's talk about programming. In programming, it works the same way. So you can have this legit, tight, awesome application, right? And over here, there's people, and they're like, hey, we want to use your application, but we're probably going to break it. Well, in this situation, an API would be useful. And what it does is it allows you to allow people to do certain things, and it allows you to prevent people from doing certain things. So the only way they can communicate with your application is from certain endpoints that you allow them to. So since this application is so legit, let's not even draw it as a square. Let's draw it as like some crazy shape, right? This is kind of like an interface layer. And the only way these people can talk to your application is using these certain points that you allow them to use to communicate with your application. And this is like very basic explanation, and the way you apply an API in different situations is going to be different. But you can think of it as this extra layer that you add on to your software that allows people to communicate with certain parts of your application. A couple examples of interfaces in programming are operating systems. Operating systems are a layer between your hardware and your software. The job of the operating system is to act as an interface between these two, filling the gaps so the operating system can meet the needs of both the hardware and the software. Without the operating system, you would have to program directly onto the computer hardware, which we don't want to do that, because then if you have different hardware, you're going to have to make a whole different application. Another example are applications that work with a database. You can think of the database over here, and then you have the application that you use, and then here's you. You don't get access to the database. The only way you can get access to the database is to type on your application thing. So whatever the application is, whether it be an accounting application or whatever, you are very limited in what you can do. You can't be like, LOL, delete database, because the people who made the database don't want you to do that. Well, in the MySQL context, procedures are an API over your database. So here we have the database, and then here we have procedures. Here we have programmers. Here we have the software they develop, and here we have the users. So by adding this extra layer of procedures, you are creating an interface between the programmer and the database. And that's good for two reasons. One, it simplifies what the person needs to know about programming in database languages. And two, it's a security measure, because if you have multiple programmers, you can allow certain ones to access certain different procedures. So that way they can't just be like, yeah, I quit, and by the way, I deleted your database. So yeah, you guys get the idea. And you can think of procedures as an extra chain in this link to the users. And it just allows for easier application development in some situations. If you got like SQL pros, having an extra person just to create procedures might just be a big waste of money and time. It really depends on what you're doing, the security of what you're doing, and everything else. Now there's one thing you need to know, that when you're giving these people user permissions, you have to do some definition within the procedure. So you can say, this person is allowed to use this procedure. If you want to know more about that, just go on Google and search SQL Security Invoker. And that's something you can add into your procedure definitions by just putting one of these people's usernames, for example. And you can find that in the MySQL docs. Another thing, if you're looking for the term that describes simplifying things by creating an interface, it's known as an abstraction. Operating systems, for example, are an abstraction over the hardware layer of computers. That way we don't need to know every single thing about the hardware. Same thing for databases. This layer of procedures is an abstraction over the database, preventing us from having to know every single thing about the database to write our commands. So yeah guys, that was a pretty awful video over application programming interfaces. And those who actually create them probably are laughing at me right now. But that's all I got for you guys for now, so hopefully that was useful, and I will see you guys in the next video. Thanks for watching. Hey, welcome everybody. This video, we are going to be creating our first stored procedure. If you want to get the exact setup here, you can go back to our last on-screen video, and in the description there will be a link that'll take you right to this point. Now we're going to be continuing our work on our, we'll just say this is a pet dating site. Because that's not weird at all. So the very first thing I want to do is add a new row into our table. So I'm going to add a comma there instead of a semicolon and just enter some new data. We'll give it an ID of 3. I'm going to introduce you guys to a pretty cool function here, which is now. That'll just give us the current date. So that'll work perfectly in this situation. And then for this, I'm just going to put null to say that this horse is still alive. And now the semicolon is going to need to go here. In the last few videos, I talked about the delimiter keyword, where you say delimiter and then you can say // for example. And what that'll do is change the delimiter so anything within the stored procedure gets sent to the server rather than being interpreted. Well, it works a little bit differently for SQL Fiddle. In SQL Fiddle, there's this little box down here, which by default, it's on semicolon, but I changed it. And you're going to want to change it to something else. And I'm pretty sure the way this works is that whenever it comes across a stored procedure, it'll automatically just interpret it that way. So we don't need to say delimiter here. All we need to do is say create procedure. And we'll just say pets _ female. And what this is going to do is get all female pets. And the reason I kind of name it backwards rather than female pets is because when you have a bunch of procedures, it's probably easier to see them alphabetically by the object. So we know right from reading this that this is working on pets, the pets table specifically. So after this, we just say begin. And then when we're done, we can say end and put our new delimiter. So you can see how this is a little bit different than the MySQL client, because with the MySQL client, we would have to go up here and say delimiter // and then down here we would say delimiter semicolon. But that's not going to work in SQL Fiddle, and I think PHPMyAdmin as well. So all of our procedure code goes in here, and I'm just going to press tab just so it's clear where the code actually begins. And we're just going to select everything from the pets table. And we'll use a where clause to say sex equals F. Let's build our schema and see if everything works. There we go. Now to call it, all I have to do is say call pets _ female. And the semicolon actually is not needed when you only have one statement over here. So let's run it and see what happens. Snowflake and Princess are returned, which is exactly what we wanted because those are the only ones where they are female. So all you male pets out there, if you're looking for a hot lady, this is the procedure that you're going to want. Let's create another procedure. And in this situation, we're going to show how we can use variables and execute multiple statements within one procedure. So that should be capital. This is going to be pets female with birth date. And this is more just to show you that you can run multiple statements within one procedure. So what we're going to do is we're going to create a variable and we'll just name it birth date, and we'll set that equal to a string of 2015 0328, and then we're going to say select everything from pets where sex is female and birth is equal to birth date. Then we can end that procedure. Let's build it. Boom, it works, no errors. So it seems to be working, and you want to look down here at the second result table. It returned back Snowflake, which is in fact the row that we did want to return because that is the one with the birth date that we specified. And this might show you just how useful parameters could be in this situation, we are hard coding the date in here. Wouldn't it be cool if we could just over here say 2015-03-28, and then it would return all of the females with that birth date? That would be a lot more useful. But we'll be talking about parameters pretty soon. But just for now, understand that this is not the best way to structure our procedures. And we'll get into that more as we go on. So thanks, guys. I will clean up this code a little bit, and then I'll put the new URL in the description for you guys to get. So if you're having any issues, just go to that URL and it should be working fine. Thanks, guys, and I'll see you in the next video.